Welcome back. We learned about our basic Python data types. We also learned a little bit about some of the terms that we might use when talking about code. We learned a few best practices, but most importantly, we learned how to perform actions on these data types. We saw that there's built-in functions that we can run on any data type, such as the print function. But we also learned that most of these data types have their own methods. That is, that dot some sort of a name and then the brackets to perform some actions on them. Now we're still scratching the surface here, but we now go into an area that gets really, really exciting. Because up until now, what we've been doing is this. Every time we write code, we do something here, and then we go to the second line and do something else, and then finally go to the third line and do something else, and so on and so forth. Our Python interpreter just went line by line, one all the way to whatever line number we have on our .py file, and just ran the code. And it ran it really fast because machines are good at that. They run code really fast. But we haven't discovered the true power of programming, and specifically programming for machines. You see, the power comes when we start to incorporate the idea of maybe running multiple lines over and over, or maybe skipping a line and going from line 1 to line 3. And in this section, we're going to talk about the idea of conditions and conditional logic. We're going to talk about looping and loops, where we can perform actions hundreds, thousands, millions of times over and over, something that machines are really, really good at. And that's when programming becomes really powerful, because machines can do certain tasks a lot better and a lot faster than humans. So we're now going to break into a new world where instead of going from 1, 2, 3, everything in order, we're going to start to break some of that apart so that we have more control over our programs than just going line by line. Let's find out how to do that in the next video. Let's talk about conditional logic, an important concept all over programming. What do I mean by conditional logic? We've learned about booleans, right? We have true and we have false. And some of you might be wondering why they're so useful. And when it comes to conditional logic, booleans are really, really important. For example, let's say we create a variable, is old. And you know what? We're going to create a car that automatically detects if you can start the engine. Maybe if you're not old enough, the engine won't start and it won't let you drive. So that they make sure that this car is super safe and only people that are perhaps over 18 can drive it. So how can we code something like that? Let's assume Tesla has a new feature like that. Well, we'll have something like is old, and we'll set this to true, right? Maybe we have something else. Maybe it checks the license to make sure that we have a license. So we can say is license. And then we can set it to true. Now, these could change, true and false, depending on the user and the driver. But when I talk about conditionals, this is what I mean. In Python, we can use the if keyword to say if some condition exists, and this is just me writing it, it doesn't exist. You can see that I get a red underline with invalid syntax. But here we want to say a condition that evaluates to true or false. In our case, we can say, hey, if is old, which what does it evaluate to? Well, it evaluates to true. If that's true, then let's say print you are old enough to drive. Now, there's a few new things here. One, I've added a semicolon or a colon, and then you'll see here that the indentation is different. As a matter of fact, when I press enter after the colon, you see that it automatically gives me a space. This tells the Python interpreter, I'm going to do an if statement, a conditional operation. And if this happens to be true, run everything that's inside of here that has this indentation. And if I do something without the indentation, let's say print check, check, this to the Python interpreter is like a completely new line. It is not part of this if block. And if you're using the REPL, you see over here I get a little minus sign. If I click this, you see how it hides? Well, what it does is it's saying, hey, this is a code block over here. It's an entire thing in itself. But anything outside that is not indented, well, doesn't belong to it. So to a Python interpreter, it's going to say, I have this line, and then I have this line. Let me show you what I mean. If I run this program, I get, you are old enough to drive, and then I also get check, check. But what if I say is old is now false? What do you think will happen? If I run this, I get check, check. Our Python interpreter is going to say, hey, set variable is old to false. Hey, set is licensed equals to true. And then it's going to go to line 3. Nope, nothing there. I'm going to keep going. Line 4, hey, if is old, is this true? No, if old is false. And the interpreter is going to say, okay, I'm only supposed to run this piece of code if this is true. Because this is now false, I'm just going to completely ignore what's underneath here and just go to the next line that has, well, no indentation. So it's going to print check, check. And this is the power of conditionals. We're able to essentially skip lines. The interpreter doesn't even care what's in here because I just told my program to skip from line 4 to line 6. How cool is that? So we learned that there's this if keyword, but there's also another thing we can use called else. And you'll notice here that I didn't add it to the indentation. And else, as the name suggests, simply says, hey, if this something is true, then do this. Otherwise, also else, do this. And again, you see that I've added the indentation. So try to guess what's about to happen in this program. If I click run, I get check, check, because it's saying, hey, is old, is that true? Nope, it's not true. Okay, I'm going to completely ignore that. The interpreter sees else. Okay, well, this wasn't true, so I'm going to run. Whenever this evaluates to false, I'm going to always run print check, check. What if I change is old to now equal to true? What will happen next? Well, I get you are old enough to drive. Else only runs if the if block of code evaluates to false. Very, very cool. All right, let me ask you another question. What if I did print here? And let's change this to you are not of age. If I run this, is that what you expected? Well, I hope by now you agree that this is the expected behavior. Because is old is true, I'm going to print this. And then Python interpreter is going to say, well, this was true, so I'm going to completely ignore the else block and then just go to the next line. What's on line 8? Nothing. So I'm going to go to line 9 and I'm going to print okay, okay, okay. As you can see, we're now controlling the flow of our programs, where instead of going from 1 to 9, just line by line, we're now saying at line 4, do some sort of check, and based on that, skip a few lines. Very, very cool. All right, there's one other thing I want to show you, and it's the if. And I know this kind of looks weird. You would think that it'll be else if, but no, no, no. It's if. And what do you think this does? Well, you use it in combination with if. You say if something, if otherwise, else, if another condition, so let's say is licensed, then do another condition. So let's say print you can drive now. So let's go through this again. I'm going to say, is this person old enough? If that person is old enough and this evaluates to true, well then I want you to run this. Otherwise, I want you to run this condition. Hey, is this true? No. If it's not true, then jump to else. So what will happen here? If I click run, we get true for the first conditional block right over here. So automatically Python interpreter is going to say, well, we just got true here, so I'm going to ignore this and ignore this, and then print okay, okay. But let's say that is old is now false. What will happen next? If I click run, this is false, so Python interpreter is going to say, nope, not going to care about this block. And I'm going to go, hey, else if a condition, hey, is this person licensed? Yep, they are. So I'm going to print you can drive now and ignore else. So it works like this. What if both of these were false? Well, as you can imagine, the Python interpreter is going to ignore. It's going to run this, say, nope, this is false. This, nope, this is false. And then finally, it's going to run this. You see that else is a catch-all. That is, if none of these conditions are true, then we're just going to run this. So it's a backup in a sense. Hey, if all things fail, then just do this. Very, very cool. Now, if you look at this program, you're thinking, this program doesn't really work that well, does it? I mean, we're checking if the person is old and if person is licensed, but shouldn't we check both? We want somebody who has a license and who's old enough to drive. This is a buggy program. If we implement this in a Tesla, well, we're gonna get a lot of lawsuits, right? Because we can get somebody who's maybe licensed but isn't old enough, which I guess doesn't make sense. But we can get somebody who is old enough but never got their driver's license, and somehow we get access to the car and they can start the engine and drive, and that's a lawsuit waiting to happen. So how can we fix this? You know what? The power is that this is an expression, right? An expression, if you remember, is something that produces a value. And that means that this doesn't have to, just have true here. It could be an expression. So I could say, if is old and is licensed, then I can do that. And this is something new that we haven't seen before, the and. This is another keyword in Python. And in an upcoming video, we're going to talk about more of these keywords. But this should read like English, right? If is old and is licensed, then do this. So we can now remove the elif, and then here, both expressions need to evaluate to true. That is, whatever happens here, this has to evaluate to true, and this has to evaluate to true. And only when both are true, again, as and states, then you're old enough to drive and you have a license. So that if I run this, well, I get an error, right? Because, or not an error, but it goes into the else block because both of these are false. If only one of them is true and I click run, you are not of age because both of these have to be true. If I click run, hey, all right, the car is starting. You can drive away with your Tesla. Okay, before I finish this video, because this is a lot, I want to just note one thing. That is the elif statement. The elif statement is really, really useful because when you have code like this, where you have an if statement and an else statement, usually you only see one of each. I mean, sure, in another part of the program, I could have another if statement and an if statement with another else statement inside of here. But usually, when you have this grouping together, you only see one if and one else, but you can have multiple elifs. So I can have elif another condition here, and then I can have another elif another condition here. And you can have as many as you want. Eventually, the program is going to either evaluate one of these conditions to true, or it's going to go into the else block. But usually you follow this order. All right, that was a lot. Let's take a break and explore this topic a little bit more. I'll see you in the next one. Bye-bye. I want to add a quick note about this spacing that we see in this code. Now, this isn't just for Python. In other languages, you'll always see this. You're not going to see that every single line of code always starts as, well, in the first space. Different languages will use this differently, but in order to organize code, usually you'll see some indentation like this. Now, Python, however, is unique because the indentation and spaces that we see here makes the interpreter see it and say, hey, this means something. The interpreter would actually see the space and say, because there's space here, I know that this is part of the if block. In other languages, like JavaScript, well, you have something similar, but usually you'll have an if statement and then some condition, followed by, make sure I spell condition right, followed by something like a curly brace. And in here, whatever is in here, you can see that I still get the space and I can do whatever I want. But JavaScript interpreter doesn't really care that there's spaces. If I want, I could write my code just on one line like this, and it's still valid JavaScript code. So people usually do this spacing more for style purposes. Python, on the other hand, is not just for styling that we do this, but because the interpreter actually finds meaning in the spaces, which is actually one of the big selling points with Python. It's very clean. There's no extra stuff here that makes it difficult. I mean, it's just English, right? If is old and if is licensed, then print this. It's just really nice to read and really clean. Now, if you notice here, my editor, and we're going to talk about editors and IDEs in an upcoming section, but if you are using the proper tools, this automatically is created for you. Now, in the programming world, there's this debate about tabs and spaces, and we're not going to get into it. It's frankly a little bit silly. That is, some people prefer to here, if they want to create a space, they might use spaces or they might use tabs. At the end of the day, with Python, the rule is you can use spaces, you can use the tab, but the idea that if you use spaces, you usually use 4 spaces. It's just a standard. Now, if you notice here, I actually don't have 4 spaces. It's 2 spaces here. And that is because up until now, well, I've just been following along whatever this editor gives me. But if you look over here, there's an auto format button. If I click on this, it automatically formats my code into the appropriate format. And you see right over here that I now have 4 spaces. But you see that the code still works. Again, it's because at the end of the day, the important part is that there's a distinction between hierarchies. That is the top and then maybe the children. But the interpreter itself is going to notice these spaces. So you do have to be careful because based on where this print is, as soon as I add a tab in here and I click run, well, I get is old and is licensed. But as soon as one of this is false and I click run, you see that OK runs only if this condition fails. Again, if previously both of these were true, I only get the first line printed. So that little space here changes the outcome of my program. So you have to really be careful with this. And luckily, your editor or where you code is going to help you out with this. But it is a gotcha that if you're just starting out, you want to be mindful of. All right, no more debates about spaces and tabs. I'll see you in the next video. Bye-bye. Welcome back. In this video, I want to talk about the idea of truthy and falsy. What do they mean? And you'll hear this a lot in Python programming. You see, up until now, you've used booleans here as values. So it was really easy. If true and true, then run this code. But Python can do other things as well. For example, if this was 5 and this was, let's say, hello, what do you think will happen here in our program? Well, if I click run, you are old enough to drive and you have a license. Is that what you expected? And this is because what Python does underneath the hood is actually convert these to booleans for you. So it's almost as if it is doing this. Remember type conversion. We're converting the type to boolean as soon as we get to this if statement because Python is saying, hey, I want true or false. I don't care what is old is. I don't care what is licensed is. Just give me true or false so I know whether to do this or to go to the else block. Now, if I was to just print, let's do this here. Let's do print boolean hello, and then finally print boolean 5. Let's see what we get. We get true. And this is what we call a truthy value in Python. That is, it's a truthy value because if we run the boolean type conversion on it, it evaluates into true. What's a falsy value? Well, if I do 0 and if I do, let's say, an empty string and I click run, those are falsy. That is, it's not actually false, but it is falsy because if we run boolean on it to Python, it's going to say, oh, this is false. And 0, that's false. And that kind of makes sense, right? And if you actually go to Stack Overflow, if you've never seen Stack Overflow before, if you ever have programming questions and you're Googling them, usually the top 5 answers will contain either 1 or 2 Stack Overflow answers. And basically what happens is people ask questions like, what is truthy and falsy in Python? And you get answers. So you can see over here that it has 4 answers. And you usually look for the check mark, which means that this is a verified answer. It means that, hey, this question owner has accepted it as the best answer. So the person who asked this question just said, yeah, this is the right answer. This is the best one. But you also have other people voting. So you can see that this answer received 46 marks. And although it was marked as the correct answer by the user, maybe somebody else came along later on and gave an even better answer. So now we have 123 upvotes. And you see that this answer is a lot better. All values are considered truthy except for the following. So you can actually see here that in Python, these values are considered falsy. You can see 0 here, you can see an empty string here, and then there's a few other ones. Empty set, you have an empty dictionary, empty list, empty tuple. You have decimals. You have things like fractions. You have 0.0. False is that. And also none is falsy. So that if I type in none here, that's false too. Now you don't need to memorize these because most of the time it makes sense, right? But it helps us do conditional logic very nicely. For example, let's remove this. And let's say that we have a user. And this user has to have a password and a username. If, let's say, the username is Johnny, and the password is 123. Well, instead of me saying, hey, if this user has password and username, and we're not checking if the username exists or password exists, we just want to make sure, hey, did this person fill out the form and did they try to submit a username and password? I can just simply say password and username. And I don't have to worry about converting this to a Boolean or anything like that, because if password and username exist, then try to log them in. And you see that it reads a lot nicer, because each one of these get evaluated into a truthy and falsy value. It's a nice little feature to keep Python, well, nice and simple and reading like English. I'll see you in the next video. Bye-bye. I want to talk to you about another way to do conditional logic. We saw the if, elif, and then the else statement. But there's another way called the ternary operator. Now, this is still the same as the else if or if else statements, but it's a shortcut. So you can only use these on certain conditional logic. So it doesn't mean that, hey, this is just an entirely new way. This is a shortcut in a sense for you to make your code a little bit cleaner. Let's have a look. By the way, these ternary operators can also be called conditional expressions. And when you hear the word expression, that should mean something to you, right? It's an expression because it evaluates to a value. So a ternary operator or a conditional expression is an operation that evaluates to something based on the condition being true or not. And it's actually a new feature of Python as of version 2.4. So let's have a look. The way we use this is to say is condition, if this is true, then do this. So this is the condition if true. And bear with me here, it is a little bit confusing at first. We say if, and here we give condition, otherwise condition if else. All right, that is a little confusing. So let's go through it. So the if is going to check this condition. So it doesn't actually start with here. It's going to say, hey, if this condition. Now, this is going to evaluate to either true or false. If it's true, then we're going to do this. Otherwise, we're going to do this. So let me show you an example of how that would work. Let's say we're trying to determine if a user is your friend. So we'll say is friend. And here we can set true or false for friend. Maybe we can check on Facebook if users can message you. Or on Twitter, whether Twitter users can give you direct messages. Well, here, and let's do can message. And here we can do our ternary operator. We're going to say message aloud if, so this is if the condition is true. The condition is, hey, is this person your friend? Otherwise, condition that is false, well, I'm going to say not allowed to message. And you can see here that this is a one-liner. It looks like 2 lines, but you can see over here that it's not really. It's just that we're wrapping so we can see the entire code. So let's run this and see what can message prints. If I run this, message is allowed because, well, we've assigned message allowed to can message because, well, the condition was true. If this person wasn't my friend and I run this, not allowed to message because the condition, the if condition, evaluates to false. I know the ordering here can be a little bit confusing, so you might have to look at it a couple of times, and you do need to use it a few times to really remember it, but this is the general rule. Condition if true, if condition, else condition if. Not if else, if false. Can't spell. All right, a nice shorthand way to do something when a condition is either true or false, or evaluates to true or false. All right, I'll see you in the next video. Bye-bye. It's time to talk about another topic that sounds a lot more confusing, short-circuiting, than it actually is. It's quite simple. Short-circuiting looks something like this. Remember when I taught you the word and? So we can use, let's say, for example, is friend equals to true, and let's say is user is equal to true. And I can do an expression here saying is friend and is user. Now, in here, when we run this, let's print it here just so we can see. If I run this, I get true because both of these evaluate to true. So that if I had this as an if block, let's say if it was if is friend and is user, print best friends forever. Now, short-circuiting can be done when we use something like or, which we haven't seen before. But again, you can see here that it's highlighted in blue, so it is a keyword, a Python keyword. Now, or says if either one of these conditions are true, then run this piece of code. So if I run this, I get best friends forever. Now let me ask you this. Which operation do you think is more performant? The or the and? Is there a difference? As a matter of fact, there is because of short-circuiting. You see, when I do or here, because I only care if either one of these is true, the Python interpreter is going to say if is friend, and it's going to evaluate that and say, oh, this is true. And then it's going to see the word or, and it's going to say, hey, I don't care what this is. Maybe this is a really heavy operation or something that I need to look up. Well, I don't really care because this is already true. Whether this is true or this is false, I don't really care because either way, I'm going to have to print this. As you can see, it still prints best friends forever. So short-circuiting happens when the interpreter is smart enough to say, I already did enough work. I don't care what this is. This is just wasted work if I do it. So I'm going to short-circuit and say, hey, I'm going to just ignore this and I'm going to start printing. So using or is a little bit more efficient. But again, it depends on what you need. If you need to check if both is friend and is user is true, you'll have to use and. But this works both ways with and as well. For example, if is friend is false, this is going to get short-circuited because I'm going to say, hey, if is friend is false, well, I don't really care what is user is because there's no way that both of these are true. I've already seen that one of them is false. So I'm going to ignore this and I'm going to print this. And when I say I mean our good old friend Python interpreter. Now, this topic of short-circuiting doesn't really get taught in beginner Python courses, but now if you hear this, maybe you hear this in an interview, as you can see, it sounds a lot more difficult than it actually is. And frankly, it makes a lot of sense, right? We want our machines to be efficient, and it is quite efficient due to short-circuiting. I'll see you in the next one. Bye-bye. Welcome back, and let's talk another term. Logical operators. And they're very, very useful when it comes to conditional logic. Let's have a look. Logical operators are, well, as a matter of fact, you've actually seen them before. And is a logical operator. Or is a logical operator. It allows us to perform logic between two things. What else is a logical operator? Well, let me list it out for you. We have greater than, less than, equal to. Let's actually use them in an example. Is 4 greater than 5? Well, if I print this, what do you think will happen? Shouldn't be a surprise. That's false. 4 is not greater than 5. This is a logical operator that you may have seen in math class. If I do the opposite, is 4 less than 5? That makes sense. That's true. What about is 4 equal to 5? If I run this, I get false. Now, why did I use 2 equals here? Why not just do this? Well, if I run here, I get an error. Syntax error. Keyword can't be an expression. It's because, remember, equal is what we use to assign to a variable, right? And if you remember, I told you that a variable in Python can't start with a number. It has to be a letter or underscore. So when I do this, it's going to error because the interpreter is going to say, hey, I'm trying to assign variable 4 the value of 5. And, well, that's not really allowed. So we use double equals to tell the interpreter, hey, I'm not assigning a variable here. I want to compare things. And we can compare different things. I can do hello equals to hello equal to true. What if I do A is greater than B? I get false. Now, why is that? This I want you to Google on your own and figure out why is A greater than B. What if I do A, is that greater than capital A? That's true. This is interesting. And this is actually quite an interesting reason. So I know it's easy for me to just give you an answer, but I want you to practice Googling this. And the reason I'm not giving you an answer is it's also because it's not very important. Because most of the time, you want to make code that is easy to understand and understandable. You're most likely using greater than and less than with numbers. So if you see something like this in code, well, you wouldn't know what's going on. What is this person trying to compare? Why are they doing is lowercase a greater than capital A? It's not something that you see very often. But the reason you get this expression is quite interesting. So I do recommend you Google into it. Like I said, I'm a strong believer in not holding your hand the entire way. I know so far the videos up until now have been quite easy, especially if you are an experienced programmer. But as we progress, you'll see that after this course, you need to figure things out on your own. And my job is not to just handhold you the entire way. It's to develop the skills in you to become an employable programmer. So I hope you bear with me as I just give you this little challenge. All right. We went a bit on a tangent, so let's bring it back. Can I do things like this? Is 1 greater than 2? Or you know what? Let's do less than 2 and less than 3 and less than 4. Will this work? Well, of course it will. It's just an expression, right, that we're evaluating. And all of this is true, but as soon as I change and something is false, it's going to short circuit, which we learned about previously, and return false. All right, so we know the greater than, equal to, less than sign. We also have greater than or equal to. So that if I do 0 here and I click run, I get true because it's saying, hey, is this greater than or equal to 0? I can also do less than or equal to 0. And here I get false because 0 or 1 is not greater or equal to 0. But if I do 0 here, I'll get true. Here's another one. What if I do this? Exclamation mark equal. This means in Python not equal to. If I run this, I get false. And this is a little tricky. What it's saying is, hey, is this not equal to this? So it's the opposite of doing equals. If these two things don't equal, it's going to say true. So if I do 1 here, I'll get true because these two things do not equal. So we've learned greater to or less than, greater to, equals, equals or greater or equal to. We've learned about less than or equal to, We've learned about not equal to, but we've also learned about and or. And finally, there's one more I want to teach you, and it's the not keyword. I know, it's a little much, but it's not as hard as you think. Not is, well, the opposite. So if I do here, not true, what do I get? I get false. And you see that not is also a function. So it's a keyword, but also a function that we can use. If I do not false, again, I just get the opposite. What if I do this? What if I do not 1 equals to 1? What will I get here? I get false, because this expression evaluates to true, and then not just does the opposite. So let's take a break here and work on a little bit of an exercise to make sure that we understand this. Welcome back. Let's do a fun little exercise. We just got hired by a gaming company, and we're creating this wizard game. And this wizard game has the is magician in the user's profile, and for now we'll just set it to false. We also have is expert. And whether this user is an expert at this game, we'll leave it at true for now. And then, let's do this here. I want you to check if both, or check if magician and expert. And if that's the case, if true, then I want you to print you are a master magician. And also, I want you to check if magician, but not expert. If that's the case, I want to just print at least you're getting there. And then finally, let's do a check that says if you're not a magician, I want you to say, well, you need magic powers. Now, I want you to use what you've learned about logical operators to create this conditional logic. You can pause the video if you want and try it yourself in a REPL. Otherwise, I'm going to keep going with an answer. But you should be able to solve this fairly easily if you've been following the videos and exercises so far. So let's start with the first one, where we say you are a master magician. So I'm going to say if is expert and is magician, I'm going to print you are a master magician. So I'm going to copy that and say print you are a master magician. Nothing too crazy here. And then next one, I'm going to say if, or I could even say elif if I want. And again, this is something that you can decide what you prefer. I usually like using elif if it's part of the same concept as the first one. In this case, yeah, we're still trying to figure out what type of user it is. So we'll use elif and we'll say elif. We want to check if it's a magician. So that is magician. So we're going to check if that's true. But we also want to check if, well, not an expert. Now, how do we do this? I mean, we could say use short circuiting and say is expert. And even if this is false, we can get true here because is magician, short circuit, and print this part. At least you're getting there. Because the interesting here is that this code block is never going to run if both of these are true, because in the first if block, we're checking that. So that as soon as this is true, we're going to completely ignore the elif. So we could do that, but this is a little bit hard to read because I really have to think about it. If I come back to the code or somebody else looks at my code, it's not clear that unless I comment that I'm checking if it's magician but not expert. Because this will never run if is magician is false, then that's what they're checking for. I know it's kind of confusing even saying it. So I prefer using something like this, using and not. And that reads a lot better, right? It makes a lot more sense. Hey, if this person is an expert and magician, do this. Otherwise, if this person is magician and not an expert, then print this. That reads pretty nicely. And yes, you can do this because remember, not is simply checking and inverting whatever the Boolean expression is. So this still evaluates to a Boolean that and can check. All right, let's finish the final one. If you're not a magician, you need magic powers. So how do we check here? Well, we can do another if and say not is magician. And if I run it like this and say print, and we'll just copy here, you need magic powers. And let's remove the comments for now, just so we can see the blocks of code. And we're going to test our program. Hopefully we coded it properly. Hopefully there's no bugs, but let's have a look. If I run this, you need magic powers. Why is that? Well, if magician is false, none of these are going to work. What if I change this to true and I click run? All right, I am a master magician because I'm an expert as well as a magician. What if I turn this to false and I click run? Hey, at least you're getting there. I'm a magician, but I'm not an expert yet. I still need to improve my gameplay. Now, you may have gotten a different answer than me. And there's many ways to do this, right? You could have used an else statement. You could have used or. Conditional logic is all about writing code that makes sense, not only to you, but for other people reading your code. The idea is not to be extremely clever or really worry about short-circuiting. Yes, it can be more performant, but a machine is so powerful that just tiny bit of optimization there is usually not worth it when you're losing perhaps readability. So you want to make sure that your code reads like English. And this is a topic that, frankly, a lot of beginner programmers have a hard time understanding, where they try to be as clever as possible, write as little code as possible in the shortest possible lines, when instead you want to focus on readability. Because a code that is easy to understand is a sign of a good developer. And I hope looking at this, you're thinking, yeah, this is pretty easy. I mean, this all makes sense. But this is not the only way. Maybe my version of what reads well is different than yours. The idea is to each of us try our best to make our code simple and nice. And in programming, there is no one right answer. There are many ways to solve a problem, but the key is to solve it in a simple manner that is readable. I hope you had fun, and I'll see you in the next one. All right, in this video, I'm going to try and trick you. I want you to look at these expressions where I'm checking for equality, right? I'm saying, hey, does true equal 1? Does empty string equal 1? Do two arrays that are empty equal, well, each other? Now, pause the video here and try to guess what the outcomes of this are going to be. Ready? By the way, if you get 100% on this, well, good for you, because if this was my first time learning Python, I wouldn't get this. Let's go. Is that what you expected? True evaluated, so true equals 1, evaluated to true. An empty string equals to 1, evaluated to false. That makes sense because they definitely don't equal each other, right? An empty array doesn't equal to 1. And a 10 equals 10.0. and then both arrays that are empty equal to true. Now, the reason I'm showing you here is that the double equals checks for equality or equality of value. That is, if, for example, the first one, true equals to 1, there's two different types. One's an integer, one's a Boolean. It will convert them into the same type. In this case, this will be converted like this to a Boolean value. And if you remember, 1 is truthy. So this will evaluate to true, which is why we get true. What about the other one? Well, an empty string is falsy, so it evaluates to false, and false doesn't equal true, right? Because we're checking for equality here. So one of these gets converted to the other's type. What about an empty array? Again, an empty array is actually falsy. So that's not going to equal 1. A 10 equals to a float of 10.0. That gets converted to an integer or a float, and they're going to equal each other. And that's an expected behavior. And then an empty array, well, equals an empty array. If I add in this array 1, 2, 3, 1, 2, 3, and I click run, I get an invalid syntax. Oh, because I have this here. Let's run that again. I get true. That makes sense. Let's change this to 1 and see what happens. If I click run, all right, still false. Now, this does get a little tricky, right? Like, should this have evaluated to true, but no, we get false. So this doesn't get converted in type versus what we had here. Now, don't get confused by this because this would be bad code. If you're checking something like this, well, obviously you should be checking two types, two of the same types together. Ideally, when you use comparison operators or logical operators like this, you're comparing two types and you're not letting Python do this type conversion, and hopefully Python figures it out for us. But I hope the double equality makes sense, because there's another check that we can do, which is. And is, well, is a keyword in Python. What happens if we change all these equal signs to is? Do you think there would be a difference? Let's have a look. If I click run, I get false for everything. So what's the difference here? Equals checks for the equality in value, such as 1, 2, 3. Well, that has the same value as 1, 2, 3 in a list. Is actually checks if the location in memory where this value is stored is the same. Let's go through that. So true, is that 1? No, true is not 1. True is, well, only true, right? That will be true. What about string 1? Is that 1? No, I mean, for 1 to be a string, that needs to be 1, right? Because the 1 string isn't only in one place in memory. It's literally the exact same thing. What about this list? As a matter of fact, let's do is array, empty array, is that, or is this list a list? Well, if we run this, I still get false. And this is a little tricky and also advanced. Every time I create a list, it's added in memory somewhere. So this is in a location in memory. But whenever I create a new list, it's created in another location. So these are two completely different lists that live in different locations in memory. So it's going to check, hey, is this in the same memory space, same bookshelf as that one? Nope, that's not it. But why does this work for things like numbers and strings? And that's because underneath the hood, these are types that are very simple that are in memory but in one location. Versus something like a list, even though this might be the same list with the same items, because this is a data structure, every time we create it, it's created in a new location. So that even if we have a variable A that contains this list, and by the way, this will be the same for all our data structures like dictionaries, sets, tuples. If I do B equals this, and I check A, is that B? Nope, they're created in a different memory space. So this, where A points, is in a different place than where B points. But if I do A equals to B, I get true because this double equality checks only the values. Now, this is a bit of a hard topic. So you might have to watch this video a couple of times. You might have to practice this a few times yourself. But just keep in mind the difference between is and double equals. Is tends to be a little stricter. You're checking for the exact thing that you're looking for versus equality, which checks the value. All right, that was a doozy. I'll see you in the next video. Bye-bye. Let's talk about loops. We've talked about conditional operators, logical operators. But loops gives us a whole new power when it comes to our machines. The concept of loops or looping in programming is really, really powerful. We saw that with logical operators and conditional logic, we're able to skip lines in our program so that we don't always go 1, 2, 3, 4, 5, 6, so on and so forth. But loops do a really interesting thing. It allows us to run lines of code over and over and over. And that's really powerful because that means we can run things thousands of times, millions of times. And this is where machines excel. Machines excel at doing small tasks over and over really, really fast. Way better than humans. So loops are one of the most powerful features of programming languages. So how do we create one? Well, it's as simple as using what we call for. Or in Python, we call them for loops. With this keyword, for, we're able to say for, let's say item in 0 to mastery, do something. So they're kind of like conditional operators. Instead of if, we have for, but then we have this thing, right? Where we have item, which, what is that? We don't really know. Well, this is a variable that we create. We can name it whatever we want. We can say I. We can say teddy bears. Whatever we want. This is a variable. And a variable is created here for each item after the in. So it's saying, hey, for every item in 0 to mastery, do something. And we've seen this in keyword before. And we'll dig deep into this later, but we call this an iterable. An iterable is something that is able to get looped over. So an iterable allows us to use this notation of a for something in an iterable to iterate over each item. In our case, if I print item here and I click run, look at that. It prints each item in the iterable, which is the string 0 to mastery. So every letter, it goes into every bookshelf in our machine's memory and prints each item one at a time. Now this works with strings, but we can also use lists like 1, 2, 3, 4, 5 that we've seen before. If I click run, again, this is an iterable. We're able to iterate over it and it grabs each item in the list. Let's do a set. Can we do this with a set? Well, if I click run, that works as well. What about a tuple? Let's do it with a tuple. If I click run, that works as well. That's amazing. What about a dictionary? Well, we'll get to dictionaries in a bit. So for loops allow us to iterate over anything that has a collection of items. So that in this case, we're looping 1, 2, 3, 4, 5 times. And you can see over here that we have the colon and then the indentation to tell Python, hey, whatever comes here, I can print item again, I can print item again. I can do it as many times as possible. As long as I have indentation, it's going to keep printing our numbers. But as soon as I open up here and print something else, well, I only get that once because it's not in the loop. So our program first runs this for 1, so it's going to print 1 3 times, then 2, then 3, then 4, then 5, and then only finally then it goes to print. You see how we're looping over and over and over. Now, what happens if I try and print item here? And I click run? Did you see that? Item gets printed at the very end here. I don't know if you can notice it, but you see that there's 4 5s. We've printed 1, 2, 3, 4, each 3 times, but 5 gets printed 4 times because this last print at the very end is, well, 5. Because by the time the loop ends, the value of item is actually 5. Let me ask you this. Can I do something like for, let's say, X in another list that contains strings A, B, and C? Could I do something like this? Absolutely. I can nest things in Python. And as a matter of fact, when we do conditionals in Python, like if statements, we can always nest those as well. Because in Python, it's always the indentation, right? So I can say print here item, and then also print, and you know what? Let's print them one next to the other. So I'm going to say print item and print X. If I click run, you see that we're printing 1 and A, 1 and B, 1 and C. Because item, we run line 1, so item is currently 1. So we're going to go to the next line, line 2, and we're going to say, we're going to loop over this iterable, and we're going to say this is X. So this is going to be 1, this is going to be A. And then Python comes back to line 2 because we're still in this loop. And we're going to say, hey, what's X now? Well, we're done with A, so let's go to B. So it's going to run B. And then C. And only once this is done does it go back out and now starts with 2, which is right here. 2A, 2B, 2C. So you can have nested loops over and over and over as well. All right, so these are loops. And right now, maybe it's not completely obvious why these may be useful. But before we get into that, I want to talk about this idea of iterable in the next video. Welcome back. I kept mentioning this key term, iterable. But what does it really mean? Iterable, you're going to hear that over and over in Python programming and other programming languages as well. And as we discussed a little bit in the previous video, iterable simply means it is an object or a collection that can be iterated over. So again, an iterable can be a list, can be a dictionary, can be a tuple, can be a set. It's a collection of items. We also saw that a string could be iterable. Now, these things are iterable. Why? Because they can be iterated. That is, iterated means we can go one by one to check each item in the collection. And you're going to hear this over and over when talking to Python programmers. So you want to make sure that you have that vocabulary. You're iterating over something. You're looping over something. So iterable is the noun, and iterated or iterate is the action of iterating over an iterable. I know, it's a little confusing. Now, many objects in Python, like I said, are iterable. But there's a few special ones that we haven't covered yet. Specifically, dictionary. We saw how lists, tuples, sets, and strings can be iterated. But what about an object? Let's say we have an object here, and this object will be users. And users, or user, will have a name of Gollum. We'll have age of 5006. Gollum's pretty old. And then we'll say can swim. Gollum, let's say, cannot swim. False. What if we use this object right here for item in user, and we print right here the item? What do you think will happen? Let's run this. Well, I get an error because I forgot a semicolon here, and we don't want equals, we want semicolon. And then obviously this needs to be a string as well. Now if I click run here, look at that. I get name, age, and can swim. So I've printed the keys of the dictionary. Now, this dictionary, we have the keys, that's great, but what if I wanted actually the values? Is there a way to do this? Well, dictionaries have 3 methods that are really, really useful when we want to loop over their keys and values. The first one is items. And with items, when I do this and I click run, you'll see that I get the key value pair in a tuple. And this is a very common pattern that you'll see a lot. Another one that we have is values. And guess what that does? That gives us the values of the dictionary. And we saw that user, just leaving it blank, gives us the keys. But we have a method that is more descriptive and allows us to show exactly what we want to do, which is keys. And if we run this, you'll see that I'm able to iterate over the keys. And these 3 methods are very common, and you're going to use them a lot in your programming career. So make sure you take note of them. Items, values, and keys. It allows us to iterate over dictionaries. But another interesting thing that you can do, and another common pattern when iterating over dictionaries, is what if you want to print, for example, separately the items, name, and Gollum. So right now we're returning a tuple. And we saw that we can do tuple unpacking, right? I can say key value equals item, and then just print key value. If I run this, you see that I'm able to print these. But there's actually a shorthand way of being able to do this. In here, in the for loop, I can say key value and just completely avoid this entire line. And if I run this, there you go. It still works. And this, again, is a very common pattern, where if you're collecting the items of a dictionary, you can separate them into key and value, or you might even see shorthand K and V. Again, these can be any variables that you want. You can name them whatever helps your code be more readable. By the way, just for fun, let's say in the last line here, I want to iterate over the number 50. What do you think will happen then if I click run? Sorry, name error. Name key. Oh, I get an error here because I haven't changed these, so let's change these back. That's not the error I was expecting. The error I was expecting was this. Type error. Int object is not iterable. Now this error should make sense now because I've said it over and over. Why is it not iterable? Well, because it's not an object that can be iterated over. It's not a collection of items. Because we learned that in Python, these are iterable. I'll see you in the next video. Bye-bye. Welcome back. Let's try a simple exercise. I want you to build a simple counter. And this counter is going to count the items in our list. What does that mean? Well, let's say I have a list, and this is a reserved word. Remember, it's an actual word in Python. So let's name it my list as a variable. And this list has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What I want you to do is using looping to loop over this iterable list and sum up the total of the list. Pause the video if you need to. Otherwise, let's see how we can do that. What I'll do is create a counter variable that will equal to 0 to start off with. And then I'll say for item in my list, I'm going to counter equals counter plus item. And then at the end, I'm going to print counter. Let's see if this works. I'm going to hit run, and I get 55, which, if my quick math is right, should be correct. Now, when doing this exercise, you may have gotten tripped up a bit. So let's think about this. Some of you may have made an error where you did the print here. But if you did the print here, you remember that it's going to get looped over. It's part of this code block because of the indentation, and it's going to print as many times as there are items. So you have to make sure that the indentation is like this so that you get the total. The other thing that you noticed is that in order for you to keep a counter or a total of all these items, you had to make sure that you had a variable outside of the loop, because the loop runs the code over and over. And you needed something on the outside that doesn't change. Because if you moved the counter to 0 here, well, every time the counter will be reset to 0. So that by the time we get to 10, counter would be 0. So you get 0 plus 10, which equals 10. And then you'd get, well, 10. So you have to be careful here that the indentation is an indication of us looping. And when you loop something and you want to keep a tally or total of something, that you have these issues of making sure that what you want to loop over is inside of this code block. But what you don't want to, if you want to have some sort of information that's outside of this loop, that you keep it like this. If you weren't tricked by this question, good job. If you were, don't worry, it's all part of learning. I'll see you in the next one. Bye-bye. When looping in Python, one of the most common tools is this range function that we get out of the box with Python. And you see here that range, well, is a range object, a special type of object in Python that returns an object that produces a sequence of integers from start to stop. Let's explore that a little bit more. If I print here a range, and I say range 100, and I click run, I get range of 0 to 100. So it looks like a tuple, but it's not. It's a range object. It's a special type of object. And range, you can give it like this, which gives you a default of 0 to whatever you give it, which is 100. Or you can just simply type 0, 100. And if I click run, it's the same thing. But where range becomes really useful, and you'll see this in 99% of cases in Python, is in for loops. You see, besides tuples and lists and sets and dictionaries and strings, you can iterate over a range. So for example, if I do for I in range, and let's just say item, or in our case, let's just do number in range. And in here, I do print number. If I run this, you'll see that I'll get numbers 1 to 100. And why is this useful? Well, using range, I was able to loop 100 times. As you can see, all the way till 99 because our count starts at 0. And we're able to loop as many times as I want. So I can tell the loop. Maybe we want to loop a certain number of times. Maybe you want to loop 10 times, where I can tell the loop how many times to run. It's extremely useful. Maybe here we're performing some action where it says, I don't know, email list. So we want to send 10 emails to an email list, for example. Well, again, I can just click run and I sent that email, well, a bunch of times, 10 times. Another neat trick is that, well, you might not even need number, right? We're not really using it in our code. And often what you'll find in Python programs is if a programmer doesn't need this variable, you just do an underscore. And this is just a variable. I mean, you could use it like this, and you'll still get these numbers, but it just indicates to other people that, hey, I don't really care what this variable is. I'm just trying to use range so that we can loop over things, let's say 10 times. Now, range also comes with a third parameter. And what that is the step over. So if I do 2, and by the way, default is 1 here. If I do 2, it jumps from 0 to 10 by 2, which is very, very handy. So what is range? Well, range creates a special kind of object that we can iterate over. Okay, what if I do right here. What if I do -1? Well, if I run this, that's not going to work because, well, let me show you why. If I change this to 0 and 10, and I do -1, it's going to go in the opposite direction. But if I did just 10 and 0, that's not going to work. If we want to do something in reverse, we just have to make sure that we add that -1. Or if we want to step back twice, then we click run. So you have a lot of options to play with the range. You can do ascending, descending. One final thing. Another place that you might see ranges, and like I said, most of the time they're in for loops, but you can also do something interesting like, let's say, a range of 10. And then if we wrap this in a list, remember a list function allows us to convert something to a list. If I run this, did you see that? Let's simplify this so that this range is going to just be 2. If I click run, you see that I loop 2 times. And in here, I'm going to print, first of all, I'm going to create a range, an iterable object that has 10 items. And then I'm going to convert that into a list. So you can see here, 0 to 9 into a list. So this is a quick way to create a list that, well, has integers. A neat trick that you'll definitely use along your programmer journey. I'll see you in the next one. Bye-bye. Let me show you another useful function that we'll use just like range. Mind you, it's not as common as range. Range, you'll see it a lot in Python code, but this other one is still very useful, and it's called enumerate. Now, what does it do? Let's have a look. I can do a for loop, and I'll say for, and we'll say character in enumerate, and then enumerate, we wrap around something that, well, we want to enumerate. So let's see what that means. It returns an enumerate object. So iterable must be another object that supports iteration. So we have to give it something that enumerate can iterate over. So this time around, let's just do a string that says hello. Now, enumerate is special because what it's going to give us is it's going to take an iterable object and gives you an index counter and the item at that index. What do I mean by that? Well, you can actually say I, comma, character. So we're unpacking this and we're saying, hey, print I and character. If I click run, look at that. I get hello iterated over. Again, if we don't have enumerate, then we would have just gotten hello. But we also, because we use enumerate, we get this I, or index, of each item and where it is in the index. So that if I had a list here, let's say 1, 2, 3, again, I'm able to use and access the index number of the item as well. What if we had a tuple? Again, we get the index number. So enumerate is very useful if you need the index counter of the item that you're looping through. So let's do a little exercise. Let's say that we want to create a script that enumerates a list of numbers 1 through 10. So we'll use range to create that. I'm going to say list, and then I'm going to say range. I know there's a lot of functions here. Range, that is 100 actually. Let's do that. And I want to be told what the index of the number 50 is. So pause the video if you need to do that. Now, here, I want it so that, let me make this a little bit bigger. I want it so that we only print the index of, let's say, the value 50. I want to know where 50 is in the list. Now, again, this is a simple example, so you can probably already guess what the answer is. But how would you code this so that only in here we get the index of 50? Or it says the index of 50 is whatever. Pause the video if you want to give it a go. Otherwise, let's try this. I'm going to do a conditional and says if character is equal to 50, then I'm going to print index, or I'm going to do an f string, and I'll say that the index of 50 is, and then I'll add the index in here. So that if I run, I get index of 50 is 50. And just to confirm, if, for example, I just print here, and let's say print I and character, I click run, we see that, yep, we have the indexes the same as the numbers. Again, not too difficult of a question, but you see here that we're able to extract this information. Again, not as useful as range, but you will see it occasionally in code. So I wanted to make sure that you're not surprised by it. As you can see, it's not that difficult. Welcome back. Up until now, we've learned that with looping, we can use for. But there's actually another way for us to loop. And it's called, instead of a for loop, a while loop. And while loop is a little different in that we say while a condition is happening, do something. So you can see that there's a bit of a difference here. For example, I can say that while 0 is less than 50, do something. Or I can say, for example, I equals to 0, and I'm going to say while I is less than 50, print I. Now, if I ran this program, what do you think will happen? Let's find out. If I click run, All right, do you see that? I don't know if you can tell, but I'm scrolling right now through all of this. It's looping, 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 looping. And you see that the programming is still running. As a matter of fact, I have to stop it because what it was doing is it was looping and looping and looping, because if we look at the code, well, 0 is always going to be less than 50. So what happened was, while this was true, we printed I. And then the Python interpreter went back to line 2 and says, hey, is 0 still less than 50? Yep, okay, next line, print. Hey, is 0 still less than 50? Yep, okay, next line, print. And it kept going, kept going, kept going. Now, this is what we call an infinite loop. That is, the program doesn't know when to stop. I mean, we're telling it to just keep going forever, for eternity. And I have some safeguards in place here, but if you did this in code, you'd get this infinite loop until your program crashes. If you actually ran this code, well, it's going to keep running until the machine just doesn't have enough power anymore, enough resources to keep doing this over and over. Everything has limits, right? So with a while loop, we have to be really careful. This infinite loop can be very dangerous. So how can we solve this? We have this idea of a break statement. And break is, well, just another keyword in Python. And as you may have guessed, if I click run, look at that. It only runs once. As soon as Python sees break, it's going to say, all right, break out of the while loop. So it's going to go to line 5, and it's going to say, got nothing there, program's done. I'm going to exit out of the program. But okay, what if I want this to be looped 50 times? How can we solve that issue? Think about it. Well, we can just simply say I equals I plus 1. And then make sure that we change this to I. Now what's going to happen? If I click run, we stop, well, at 49. We've done it 50 times. We've looped through it 50 times because we kept incrementing I over and over. So that I, each time we came back to the loop, was incremented by 1. Now a shorthand for this, we've seen it before, is to do plus equals 1. So that if I run, look at that, same thing. So we're also able to break out of the while loop as long as we're able to turn a condition into false. So you'll see this a lot as well. So to jump out of a while loop, you can either turn the condition false, or you can break out of the while loop. Now, another interesting thing that we can do with a while loop is we can have else blocks. And here, we can say print done with all the work. And if I click run here, at the very end, look at that, done with all the work. And this should read like English, right? While I is less than 50, keep looping through here. And as soon as we get to the last part, where I becomes 50, where 50 is no longer less than 50, Python interpreter is going to say, all right, I don't care about anything under there. Let's go to the next line. And I get otherwise. So in this case, we don't have anything else happening. We can print done with all the work. But you're probably asking yourself, hold on. Can't I just not do this and just make sure my indentation is at the end? Click run and that works, right? Why would I ever want to write else here? Well, else is a special case here. There is one thing that is useful. That is, if we added for example, a break statement here, and I click run, you'll see that the else statement does not print. And that is because the else block will only execute if there isn't a break. That is, if the while condition turns to false, then it's going to keep going and do the else. But if there is a break, it's going to break out of this whole thing and go to the 8th line. So a little gotcha here that you won't see else too often next to while, but there is that special case where else is used when you want to make sure that this will be executed only if there isn't a break statement. Only if the loop is finished doing whatever it's doing without the break statement. Let's take a break and explore while loops a little bit more. So when should you use a while loop and when should you use a for loop? And it really depends on the problem you're trying to solve. For example, in a for loop, I could do for item in, let's say, a list, 1, 2, 3. And just looking at this code, you know right away that it's going to be looped over 3 times, right? And I could say here, print item. But you can do this in a while loop as well. I can say I equals to 0, and then while I is less than, let's say, the length of the list, that is 1, 2, 3. Well, in that case, I want you to print I, or the item, and then increment I by 1. If I run this, I see that, well, technically here we're incrementing the I, which is the value, but let's say we had a list up here. So my list, and this list will be 1, 2, 3. Well, my list can be iterated with a for loop, or it can be iterated with a while loop, and we simply say my list at index of I. And if I run this, I get the same results. But which one do you think is better? First off, while loops are very flexible. We can do a lot because we have this conditional statement. We can loop more than 3 times if we really wanted to. So in that case, while loops are more powerful. But for loops are simpler, right? Like this code reads really nicely and really well. It makes sense. We just want to loop over something that we already know how many times we want to loop over, 3 times. With a while loop, we have to create this variable, and we have to make sure we remember to increment the variable so we don't get an infinite loop. So with a while loop, you need to make sure we remember to halt the loop at some point. So my rule is usually this. For simple loops or iterating over iterable objects, for loops are great. But let's say you're not sure how many times you want to loop over something. You're not really sure how long it's going to take for looping. So you want to say, while something is true, just keep looping. For example, let's say we're trying to go through an email list that we've collected on a website. And for each email list, we want to send an email. Well, while the list is still there, let's just keep sending emails. There are many, many cases, but one of the most useful ways to use the while loop is like this. Is to say, while true, do something. And make sure that at the end, we break. Hold on, what's happening here? I'm saying while true, wouldn't that create an infinite loop? I mean, true is always going to be true. And you'd be right if you notice that. But again, we have a break statement here. So at the end, after we run line 3, it's going to break. But now we can do something powerful like input here. And if you remember, an input is going to ask us for a prompt to enter something. So I can say, hey, input, say something. And if I click run, it's going to say, hey, say something. You know what? Let's add a semicolon here or a colon here. And let's try that again. And look at that. It's saying, say something. I'm on line 3 right now. So I'm going to say, hi. And did you see that? We just broke out of the loop. It only asked me once. Even though this was true, as soon as we got to line 4, I was done. But What if I remove this and I click run? If I say something, I say hi, and then it asks me again, hi, hi. I'm telling hi, and it keeps asking me, and we have an infinite loop. But the interesting thing here is that we can use conditional logic, right? What if we said response here and collect whatever the response is and say if response is equal to, let's say, bye, then I'm going to break. So that if I run this again, I say hi, keeps asking me, and you know what? I'm getting annoyed with you, machine. I'm going to say bye. It's going to exit it out for me. How cool is that? So while loops are extremely useful for tasks like this, where looping can happen for a long time. You don't know how many times it's going to happen. But this is something that you're just going to have to get used to with practice. Eventually, and I promise you, this happens where you'll figure out when to use while, when to use for loop. But at the end of the day, use whatever solves your problem. I'll see you in the next one. Bye-bye. Welcome back. Now, up until now, we saw the break keyword that we can use to break out of a loop. And you see here that we're able to loop with a for loop, but with a while loop, as soon as we break, we're done. We've just, broken out of the loop. But could we do that in a for loop? Let's find out. Yep, break keyword works in a for loop as well. But there's actually two other things that we can use besides break. One is called continue. And you can see here, again, blue highlighting. If I do continue here and I click run, there you go. We get our looping again. But you're thinking, why do we need this? Like, it seems completely useless, right? Well, a break, when we use the break statement, it breaks out of the current and closing loop. So when we used a break statement, we broke out of this loop, right? This whole while loop, we just exited it. And same with the for loop, we completely exited it. However, with a continue, what we're saying is, hey, whatever happens when you hit this line, continue on to the top of the enclosing loop. So the current enclosing loop, what is it? It's this for loop. So it's going to go back to the for loop. So that if I do something like print here, so that we get it printed twice, or you know what? Let's just move print down here, like that. And then same here, we're going to just print at the bottom after continue. If I click run, nothing gets printed because as soon as it sees continue, it's going to say, okay, I'm going to go back to the loop. And it's going to keep going until, the loop ends so that we never actually hit line 10 and line 4. So that becomes really useful in conditional logic as well. Finally, the third one is called pass. And pass is, not very useful. It essentially does nothing. If I click run here, and again, it shows me here, line 10, something's wrong. Well, we have to move print up to the top so that, we don't get my list of index of 3, which doesn't exist. So again, going back here, if I click run, pass doesn't do absolutely anything. It just essentially passes to the next line. So why is that ever useful? It's very rare that you'll see pass in your code, but pass is a good way to have, let's say, a placeholder while you're coding. For example, you want to loop through the for loop, but we don't know what we want to do yet in the code. Let's say that here we're still thinking about it. If I do this and I click run, I get an error here because, expected an indented block, because now the for loop or the Python interpreter is looking for the next, like, what am I supposed to do with the loop? I'm trying to loop and there's no code for me. So you can add a pass here to at least fill something for the for loop to say, hey, I'm thinking about it. I'm just going to pass it for now just so you have something so you don't bug me, and I'll come back to it. So if I click run, that still works. So pass is one of those placeholders that we can use so that there is a line of code that does absolutely nothing that we can still pass through. Again, a very rare thing to see in production code, but while you're developing, some developers like using pass. And there you have it. Break, continue, and pass. I'll see you in the next one. Bye-bye. All right. Your head must be spinning because of all these looping. That's a really bad joke. But I thought it was funny because I've been recording for hours now, and I think I'm going a little kooky. So this is going to be my last video for the day, not for the course, but we're going to do a little fun exercise. Now, I call all exercises fun. Obviously, I'm biased, but this one's especially fun. What are we going to do? Well, we're going to simulate what a computer does when we have something like a graphical user interface. That is, a computer is able to display, let's say, even an image over here, right? I can see the robot over here. I can see the mouse. This is a graphical user interface. I see pictures, I see images on my screen, these pixels on my screen, and I can control them. Well, we're going to create a basic version of this to show you how a computer would work just from the stuff that we've learned up until now, using loops and using conditional logic. So what are we going to do? Well, this is the exercise. And you can check out the REPL here, or you can recreate this, or again, in this video, you should have resources attached that you can play with it yourself. And what I want you to do is I want you to loop through this list of lists, and every time you encounter a 0, I want you to display on the screen over here an empty space. Because 0 in a computer denotes nothing, right? We want a blank on the screen. However, when I see a 1, I want to simulate a pixel, right? That tiny, tiny dot on our computers that can be full of colors. It could be green, it can be blue, it can be orange. But for our case, I want it to be a star. And using that, I want you to create a program that takes this picture that, let's say, is in our database or in our computer's hard drive and displays it on the screen using space or multiply. And all I want you to do is when I click run, I want you to display that image right here. All right, this is a little tough one and I'm kind of letting you figure out on your own, but trust me, you've learned all the tools necessary to do this. Pause the video, give it a go. Otherwise, I'm going to show you how it's done. So the very first thing I like to do is to think about what I'm about to do. I want to make sure that we have a plan in mind. So I'm going to comment first, and I'm going to say, well, we definitely want to iterate over a picture, right? So we're going to do some sort of iteration here. So that's number 1. And then in here, I want to say that if it's a 0, then I want to print an empty space. And if it's a 1, I want to print a star. All right, so that's the plan. Okay, so this shouldn't be too hard. Actually, before you get started, in order for this to work, you need to Google a special parameter or special option that you can give the print function. And as a matter of fact, the print function that you need to add, or the option that you need to add, is this end option. And if we scroll down, it doesn't display it that well, but you can see here, string appended after the last value. So the default when we print something is a new line, but ideally we might not want a new line. So when that happens, you might have to use this end option. Now, I know I left it really vague. I want you to practice Googling this and figuring out from your mistake. You're going to have a bug when you create this code. when you try to display this information. But try to solve it using the tools that you have of problem solving. All right, enough talk, let's get to it. So the first thing I want to do is iterate over the picture. I'm going to say for image in picture because, well, this is one picture right here. So this is the picture, but it's inside of a list because we can have multiple pictures. And then I'm going to loop once again over this individual list. So once again, I need to do a for loop, and this time I'm going to say for pixel because each one of this is a pixel in the image. So this is a nested for loop. Now I'm going to add a conditional and say if pixel equals 1, then I'm going to print a star. Otherwise, I'm going to print an empty string. Well, maybe not empty, right? Because we do want a space, a blank space in the image. All right, so let's see if this works. If I click run, that's not really what I wanted. I want a clear image here, but I'm just getting things one in line. And remember, this was the little trick where a print, every time it prints, it creates a new line. The default, again, if we close this, you'll see is that end equals to this escape sequence of new line. So we can change that by simply saying star, comma, end, and then I'm going to say for the end, I don't want a new line. I just want, well, a string, but an empty string. And same over here. If I do comma, end, and if I click run, all right, it's getting a little bit better, but now I have an issue where we don't have any new lines. Everything is on one line. That's not good. How can we solve this? Well, ideally, at the end of this first loop, where we're just going the image or the line in the image, at the end of this, we create a new line right here, right? So again, looking at the indentation, I don't want a new line on every pixel, which we had the first time, but I also want to add a line between the lists of rows. So maybe a better name for this will be a row in picture. And in here, I'm going to add at the end of this for loop, so after we're done looping through the entire row, at the bottom here, I'm going to print an empty line. But remember, the default is going to be a new line. So again, an empty string, it's going to default to a new line, and we're still going to have this code. If I run this, I get an error because image is not defined because I've just changed this to a row. So let's do row here, click run, and look at that. We have our beautiful Christmas tree. If you don't think this is beautiful, this is the best I could, but this is a Christmas tree. And we finally have it displaying. We've used loops, we've used conditional logic, and we used a little Googling to figure out, hey, we need this option. Now, our code works, but I want to do something better here. And in the next video, I want to clean up this code a little bit and cover a very important topic when it comes to programming. I'll see you in that one. Bye-bye. It's happening, our next developer fundamentals, and that is, what is good code? I mean, what is good? That seems so vague, right? Like when somebody says, I'm a good coder, I'm an excellent programmer, he's a senior programmer, he's an expert programmer, he's a tech lead, he's a genius. What does that really mean? Well, you can narrow it down to these simple statements. what is clean, good code? I kind of gave it away. The first one is clean. That is, we want to make sure our code is following a style that, let's say, the Python community endorses. Are we following the best practices? And Python has this great feature of auto format. And Python has standard ways of using spaces to make sure that our code is clean. I'm not using unnecessarily ugly spaces like this, or maybe making lists really weird and funky, maybe no spaces in between here. Maybe I have a lot of random comments over here. We're keeping our code clean. We make sure that every line that we have is easily readable, but also we don't have any extra stuff that we don't need in there. And this also relates to the idea of readability. Now, readability means the ability to read your own code. Maybe 2 years down the road, you're going to come back and look at the code. Are you going to be able to understand it? If you work in teams or for companies and other coworkers come and look at your code, is it easy to understand? And here, this is obviously personal preference, but most of the time the ideas are simple. For example, I'm using names here that make sense. If I had variable names that don't make sense, it'll be really hard for somebody to read my code. Maybe people will be confused why I have this print statement here. In that case, maybe I should comment in here being like, need a new line after every row. Or maybe they'll be confused why we need this as well. So depending on your style, you might want to add comments. Make sure that the naming of your variables are good, and maybe making sure that it's not only you that understands the code. The other one is the idea of predictability. And this is my favorite one. That is, sometimes people try to be really clever with their code, trying to have the most compact code, or using the newest features or some really obscure tools or functions that are not very common just to look, well, frankly, smart. But you want to have code that makes sense, that does things, just one thing really well. Now, this code is quite small, so it's quite predictable. It just has one pass through and it's easy to predict what's going to happen. We're going to print. But as we get more and more into the course, you'll see that our code is going to get larger and larger. And having predictable, easy to understand code is really important. And then finally, this is an important principle that you hear everywhere, is DRY. Do not repeat yourself. You don't want to have code that you're constantly repeating yourself over and over. Again, this is a small example, but it's very easy as a programmer to say, oh, I'm going to copy this and then I'm going to run this again so that if I click run, look at that, I have 2 trees now. This is amazing. But maybe that's not the best idea. You now have 28 lines of code, and people might be confused why we're doing this twice. Maybe instead, we want to programmatically have a counter here of maybe saying running this twice, or maybe using something like functions, which we'll learn later, to make sure that we can repeat this process over and over and over. Now, keep these in the back of your mind, because throughout the course, we're going to explore these topics. But let's say I just came onto this code and I wanted to clean it up a bit. Again, this is just personal preference, but these are some of the things that I would do. One is here, pixels equal to 1. Instead, this is kind of confusing. I'm just going to say if there's a pixel here and I know that pixels are either 0 and 1, then print here, because this is a truthy value that will just evaluate to true. So that just kind of cleaned out my code a little bit better. Next, another thing that I might do, maybe I want to make this more extensible, which might mean doing something like, let's say, fill variable that equals to the star, and then maybe empty, which equals to an empty string, and change these to fill and empty. Now, this is extra line of code. But for example, if we're doing this multiple times, instead of perhaps maybe we're running print over and over and over, or maybe we have another line of print over here, and another line of print over here, and then maybe another line of print over here that is empty. Instead of me having to change 5 locations here, I can now change just this part. And maybe instead of star, I want to display, I don't know, $sign. And if I run this, all right, I get a little different image here. But again, I was able to just change the variable, and the variable was used to fill out whatever I needed done. Now, these are all things that you do need a bit of experience to get used to, but we'll hopefully explore this throughout the course, and by the end of it, you'll have all these best practices in mind. I'll see you in the next one. Bye-bye. Welcome back. Let's do an exercise where we check for duplicates in a list. So I have some list here, and I want you to be able to check this list and print whatever the duplicate values are. In this case, we see that N has duplicates, and also B has duplicates. So I want you to print B and D as a list in here. How would you go about doing that? Pause the video, give it a go. Otherwise, I'm going to keep going with the answer. And by the way, you're not allowed to use sets for this. So for this exercise, you can't use the data structure sets. Instead, you have to just use conditionals and loops that we've learned in the past couple of videos. So give it a try, pause the video, and when you're ready, I'm going to go ahead with the answer. First, I'm going to create a variable called duplicates, and this is going to be an empty list that we're going to populate with any duplicate values. Next, I'm going to loop over this list, so I'm going to say for value in some list. And in here, well, what can we do? This is a tough one, but what I'm going to do is say if some list dot count. Remember, count allows us to count how many times an item in a list exists. And I'm going to say value so that some list dot count, and I give it A, it's going to count for me how many times A happens in the list. Very, very useful. Again, if you didn't come up with that, there's many solutions to this problem. So there's no one right answer. I'm just showing you how I would have done it. Now here, I'm going to say if that's greater than 1, in that case, that means there's a duplicate. So I'm going to add it inside of the duplicates. So let's just go ahead and say dot append, because I want to append, and in here say value. And at the end of all of this, let's just print duplicates. Now let's see if this works. I'm going to click run. And all right, I get both B and N. But I don't need this duplicates. I just need to know what are the duplicates. I just need one instance of B and one instance of N. So what we can do here is do another if statement and say if value is not in duplicates. And yes, this is a bit of a trick. You may remember that not is the opposite, right? So we're checking, hey, is value in duplicates? And not essentially says, hey, if value is not in duplicates, it reads like English. And this is going to evaluate to true and false. And then finally, make sure that we get the indentation right. We're going to append the value. So if I click run, I get B and N. Again, if you didn't get this right away, don't worry. It can get tricky, and this is one of those things that you just need to keep practicing. But you see here that I was able to use loops. I was able to use logical operators like not and conditionals like if statements to solve a problem in just a few lines of code. It's time to talk about functions. This is where things get really interesting. Because up until now, we've seen functions, right? Functions were things like print, like list, boolean. We even saw the input function to get the input of whatever the user types. And those allowed us to perform actions on our data types. But the true power comes when we can start creating our own functions. That's right, we're not limited to whatever Python gives us. We're able to create our own functions and use them in our programs. So let's learn how to do that. The way we create a function in Python, and functions, by the way, exist in all programming languages. They're very, very important. If we do def, that lets the Python interpreter know that we're about to define a function. Def is short for define. So the interpreter is going to say, all right, they're about to define a function. What's the function going to be? Well, we can create whatever we want. We use the same naming case as we do with variables to define our functions. So let's create a function. Again, we'll call it, say, hello. Just a variable that I created, but this time it's a function because we use the def keyword. Now in here, in say hello, we also add the brackets to let the interpreter know that this is something that we're going to take action on, or this is going to perform an action on a data type. We use the colon, and then within this block of code, we can say print hello. And that is a function. If I click run, nothing happened. Why is that? Well, we've created the say hello function. We've defined it, and now it's living somewhere in memory on our machine. However, in order to use a function, remember, just like we use the print function, we have to call it with the brackets. So after we define a function, we say hello. And did you notice how my REPL, as soon as I said say, actually gives me this say hello command because I've created it. And you see this purple box, which shows that it's a function. Well, we now have it available for us to use, just like we had the print function available for us to use. So if I do say hello and run it with the brackets, and I click run, I get hello. How cool is that? By the way, what happens if I run it without the brackets and I click run? Nothing happens. Because remember, in order for us to take an action, we have to let the interpreter know, hey, I want to run say hello. Now, the reason functions are so powerful is because of the principle that we've talked about, right? The idea of DRY, which stands for do not repeat yourself. Functions are really, really useful when you have things that you want to do over and over. For example, the print function, we've used it a lot. Imagine if we had to code that ourselves every single time and say what print function does. Luckily, Python gives us print because it's such a useful tool. But if in our program we want to say hello multiple times, and you can imagine this actually being a lot more complicated, maybe 10 lines of code. Instead of writing those 10 lines of code over and over, I can just define it as a function and use it anywhere I want in my program. For example, remember this, where we had a picture and we printed a Christmas tree? Imagine if we wanted to run this multiple times. Well, in order to do that, I would copy and paste this code and then add it again. And if I click run, I now have 2 Christmas trees. But look at that, 26 lines of code. I just copy and pasted the same thing over and over. With a function, we can do something like this. I can say define show tree colon, and we now have a function. But remember the indentation in Python, right? Indentation is important. We have the semicolon, we're defining a function, so we have to create that code block inside saying, hey, whatever's indented here, that's part of this function. So now that we have the show tree, check this out. I can say show tree, run it again. Maybe let's run it 3 times. If I click run, how cool is that? I'm able to do the same thing over and over by just calling this function. And that's the power of functions. Functions allow us to keep our code dry, we don't repeat ourselves, and reuse things that our machines can do over and over. And the beauty is that this stays in memory for us. Show tree now means something to this program because we've created it. So we have our own custom action that we can take. Now, what happens if I move show tree here to the top? Well, if I run this, I'll get an error, name error. Name show tree is not defined. Why is that? Well, because our interpreter goes line by line. It first says, all right, picture equals to this value. And then it goes to line 11 and says, run show tree. But we haven't defined show tree yet. So the Python interpreter is going to error out and say, hey, I have no idea what show tree is. What are you talking about? Instead, with a function, we need to make sure that we define the functions at the beginning so that Python interpreter says, all right, show tree now means this. I'm not going to run it. I'm not going to use it yet. I'm just going to keep it in memory. And when I finally come across show tree, I'll know that it means something. I'm going to grab it from memory using show tree, and then I'm going to run it using the brackets. For example, if I do print show tree without anything, without the brackets, if I click run, you see that I get function show tree at this location. This is just the location in memory. This is the bookshelf where we store that show tree function. Very, very cool. And functions are an important, powerful concept in programming. And in the next video, we're going to extend this and explore this a little bit more. I'll see you in the next one. Bye-bye. Let's talk about arguments versus parameters, which is one of our key terms that we use when describing functions. Let's see what they mean. You see, right now, our say hello function is pretty generic. Very simple, right? We're just, well, printing hello. It's kind of useful, but not really. The power of functions, beyond just being able to call this multiple times, because it only lives in one location in memory, is this ability for us to make it dynamic. For example, in these brackets, I can give it what we call parameters. So in here, we give it parameters inside of the bracket. So for example, I can give it name, which is a variable that I just made up. I can call whatever I want. And I can leave it like that, or I can keep giving it parameters, as many as I want. I can keep adding 100 if I wanted to. So in this case, let's just say this is an emoji. So these are 2 variables or parameters that I've created. And this say hello function is able to receive these 2 parameters. What does that mean? It means that we're able to use these variables inside of this function. For example, I can create this as an F string and say hello and add the name, and then finally add the emoji. And because I have these as parameters, I can use them as variables inside of this code block. Now, these parameters allow us to give the function, when we call it, what we call arguments. And by the way, the confusion between parameters and arguments, people usually say one when they mean the other. It's a little tricky, so hang in there. Arguments are used as the actual values we provide to a function. So now in say hello, I can give it a name. In my case, let's just say hi to myself. And then I can give it an emoji. And you see how my editor is giving me the hint that I should give it an emoji because, well, I defined it here. Again, something that editors help us do. So let's just give it just a smiley face with the tongue out. Now, these are arguments. These are the actual value we provide to the function. And the name of the variables that we use, that we receive, are called parameters. So parameters are used when we define the function, and arguments are used when we call the function. Define and call. And by the way, some people also like saying call or invoking the function or invoke the function. So if you ever hear those words, you know what they mean. So if I run this, I get hello, Andre, with that smiley face. And this is when functions get really powerful, because we're able to not just make generic functions that always do the same thing, but we can create functions that do things based on what parameters we give it, or what arguments we call it with. So that now I can use the say hello function to say hello to my friend Dan, and also my friend Emily. And if I click run, we've made our function more extensible. We can use it in multiple places. And if we're designing a game, well, we've just used this to greet our users. And based on the username, I can use the same function over and over. Again, we're keeping our code dry and clean by doing something like this. How cool is that? All right, let's take a break, and I'll see you in the next video. In the previous videos, I showed you how to define a function with parameters. Now, the way I've shown you this and these parameters is what we call positional parameters, or we might want to call them positional arguments. And they're called positional arguments because the position matters, right? If I change our arguments to, let's say, Andre as the second argument, and if I click run, you see that I get hello, smiley face, Andre, which maybe is not what we wanted to do. Positional arguments are arguments that require to be in the proper position. So if we defined name here first and then emoji second, you have to make sure that the first argument will be the name and the second argument will be the emoji. However, there's something called keyword arguments. And keyword arguments allow us to, well, now worry about the position. What do I mean? Well, I can do something like this. I can say hello, and in here, give it a keyword and a value. So I'm going to say emoji equals to, let's say, this smiley face, and then comma, name equals to BB. Now, if I run this, you'll see that I get hello, BB. Because I was able to use keyword arguments, I tell it explicitly, hey, I want emoji to be this and name to be this. So positional arguments, these matter, but keyword arguments, it doesn't. Now, I argue that this is bad practice because you're making the code more complicated than it needs to be. If the definition of the function is to give name and emoji, you should follow that practice and not confuse other developers, then just stick to that name and emoji. So you can still use keyword arguments, but make sure that they are in order, because why wouldn't you just follow what the function tells you? It's the same result, but at least this way you are following, well, the standard flow. And by the way, these keyword arguments, can sometimes be confused with what we call default parameters. I know it can get really, really confusing, but this is something that will come naturally to you after you practice a little bit. So I'm going to just comment this out and show you how default parameters work. Default parameters allow us to give right in here, as we're defining the function, what we want as default. In our case, let's say Darth Vader is the default name, and the emoji will be this little angry Darth Vader. Well, it doesn't really look like Darth Vader, but this is the emoji that we're going to use. So what does this do? Well, if I run my program, everything works the same. If I do keyword arguments and run my program, nothing changes. Let's make this a little bit bigger. However, default parameters allow us to do something interesting. For example, if I run another function, say hello, but I forget to give it parameters or arguments in our case, well, if I run this, I get hello Darth Vader. Because with default parameters, it says if you're not able to get name and emoji because you were called without any arguments, well, in that case, make default Darth Vader and make default emoji this little emoji. If I use, let's say, just one argument and I click run, then, well, it will fill that name variable, but anything that we don't give it, like emoji, will be predefined. So this is a great way to make sure that your function runs even if it's called the wrong way. So keyword arguments increases the readability of your code because you know exactly how we're calling say hello. And default parameters allow us to keep our functions a little bit more safe because we make sure that when we use a variable, we're going to have it no matter what, regardless of how it is being called. But positional arguments are also useful because it's nice and clean, right? We're just following what the function tells us to do, and it's easy to read. So there's pros and cons of using each, but I hope this demonstrates to you some of the ways that you can define functions and also call functions. I'll see you in the next one.